Hello guys, hope you all are doing well. So in the continuation of the previous GATE series, we have completed 1994 and today we will solve section A of 1995. So without wasting time, we will look into the question, okay? So the first two question I just skipped that because they are from maths and very simple. The first one was find the rank of a matrix, okay? And the second was the question is given two vectors and we have to find the angle between them. Okay, so those two are very basic and very simple questions. So I skipped those questions. Okay, so we'll start from question 3. So during cooking of coal, the ash content we know that increases. Okay, jigging is a technique by which different particle can be separated by different size. When you will separate by the density, it is decantation. When you will separate by the particle density, it is called decantation. Decantation. Okay, separated by the particle size, particle shape, screening. Okay, so first one is the answer. As particle attains its terminal settling velocity when, okay, so for terminal velocity we know that suppose this is particle going down in a liquid, so we know that weight, that is mass into gravity, will apply on the particle in downwards. There is a drag force will apply on the upward and buoyancy force always apply upward. So the balance will be drag force plus buoyancy force equal to gravity. So buoyancy and drag is equal to gravity. Okay. For an ideal fluid flow, the Reynolds number. We know that for ideal fluid, mu is equal to 0. When mu is equal to 0, then Reynolds number become infinite, right? Fluid energy mill, ultrafine grinding. Okay. Crushing, jaw crusher, gyratory crusher. Okay. Cutting, there are certain equipments. You can go through C.M. Narayana. Okay, very good book. For an ideal mixed flow reactor, CSTR, the exit edge distribution. We know that for CSTR, exit edge distribution is given by this. Okay, so it could be a ramp function. Okay, because ramp function is just like that. Okay. The conversion XA and residence time tau data are collected for a zero order liquid phase reaction in a straight tank reactor. Which one of the following will be the straight line? So XA versus tau will be the straight line. How? We know that tau is equal to Ca naught XA upon minus Ra. For zero order reaction, minus Ra will be equal to Ca naught XA upon K. So this will be the slope and tau versus XA will be the straight line. Okay. The dimension of rate constant for reaction liter gram mole per minute. Therefore, the order reaction is second. For to check to find the order, we know that for nth order reaction, rate constant is equal to time inverse concentration 1 minus n. Okay, so just put the value, you will get the answer. A first order reaction A that gives B occurs in an isothermal porous catalyst. Okay, isothermal porous catalyst petal spherical. So हमारे पास एक spherical catalyst petal है. Okay, these are the pores inside. Okay. If the concentration of air at the center of the pellet is much less at the external surface. So inside the concentration is very less of A than the external surface. The process is limited by diffusion within the pellet because reaction, no, external mass transfer will take place because the outer concentration is much higher than the inside concentration. When the reactant try to move inside due to the less concentration difference, because the inlet concentration is much less than the outer, there will be no diffusion within the pores. Okay, the reaction will not take place here. Reaction will take place inside the pore. but the mass diffusion within the pore is limiting because it will not allow the reactant to go inside. If the reactant will not go inside, the reaction will not take place, right? So for the reaction, the reactant must present inside. Okay, so diffusion within the pellet will be the limiting. A solid is transferred into vapor without going to the liquid phase below the triple point. We know that for triple point, this kind of things. Okay, this is line of solid, this is liquid, and this line is for vapor. So this is solid, this is liquid, and this is vapor. So without going to solid to vapor without liquid, so you have to go below the triple point. Okay. At the inversion point, Joule-Thomson coefficient is 0. Joule-Thomson coefficient, we know that mu Jp is equal to del P by del Th enthalpy constant. It is 0. Okay. Transfer function of a PD controller. Proportional plus derivative. So 1 Kc 1 plus tau ds. That is straightforward. Offset introduced by the proportional controller with gain Kc in response for first order system can be reduced by. Okay. So if you want to reduce the offset when there is only a proportional controller, we have to integrate it with integral controller. But the drawback here is the oscillation will increase. It will ultimately reach to its value. Suppose this is the ultimate value where I have to reach. So if alone proportional controller, then it will like this. Okay. Sorry, this is no controller. This is for no controller. When we are not using any controller, then offset will be this. If you are using proportional controller, then it will come little bit near to the ultimate value. So proportional controller. But if we will use Pi, then ultimately it will be like this. Okay, going to ultimate value, there will be no offset, but the oscillation will increase. That will create a problem for the system. Oscillation will increase. So offset will be 0, but introducing integral controller, offset will be 0 along with the proportional controller, but oscillation will increase. The best controller is PID. When we add all these three, the response like this. For a single oscillation, it will give ultimate value. Okay. Okay. Bode diagrams are generated for output response of the subjected to which of the following input? A sinusoidal, that is. Gas chromatography concentration. According to Bode stability criteria, amplitude ratio exceeding unity at frequency for which phase lag is 180. Okay, that means I have told you in the previous question when you were solving the questions of the Bode plot and phase margin and gain margin amplitude ratio, that amplitude ratio should not be exceed 1 and phase lag will be 180, not more than that. Okay. The response of two tank of same size and resistance is in series. Either it is interacting, non-interacting, always overdamped. The transfer function of pure dead time system with tau d is e to the power minus tau d is nothing rocket science in this. Time constant of first order reaction is RC, resistance to capacitance. Suppose for first order system, if I take first order system, if I take mercury thermometer, the time constant for mercury thermometer is mcp upon ha, right? mcp upon ha. If I write mcp into 1 upon ha, okay, so this is capacitance and this is resistance. We know that 1 upon h is the resistance in heat transfer. We know that, right? 1 upon ha is the heat transfer, is the resistance in heat transfer. And when you will take A, when you will not take A, you all will know when you will read heat transfer. Okay. So this is capacitance. MCP is capacity, heat capacity. We know that. Okay. MCP delta T from that formula, and this is into resistance. Okay. So this is the answer. Okay. A function fx 12x minus x cube has maximum value at x equal to 2. When you will solve this, I think there is no need to solve, but still 12x minus x cube. So f dash x will be 12 minus 3x square. If I'll put equal to 0, then x square is equal to 4 3 are 12, x equal to plus minus 2, then f double dash minus 2, f double dash plus 2, then you will get the answer the 2. Okay, limit x tend to 0 10x upon x. Okay, so we will apply L'Hospital rule. L'Hospital rule, but remember all L'Hospital rule only applicable when both numerator and denominator are 0 0. So if I put 10x equal to, if I put x equal to 0 here and here, then it will give the 0 by 0 or infinite by infinite. In these cases we apply L'Hospital rule. Okay, so this is a 0 by 0 form. So applying L'Hospital rule will give 10x tend to 0, 10x derivative of 10x sec square x upon 1. So sec square 0 equal to 1. So the value is 1. Okay. The second order Taylor series expansion of function at x equal to 1 is okay. So very first we will write the Taylor series f is equal to fa plus x minus 1 f dash a plus x minus 2, sorry, x minus 1 square f double dash a upon 2 factorial. So up to 2 second order we have the question is asking. So we'll write only second order. So okay. So fx is equal to x square. So f1 is equal to a, where a is equal to 1. Okay. So f1 is equal to 1. F dash x is equal to 2x. So f dash 1 is equal to 2. F double dash x is equal to 2. F double dash 1 is equal to 2. Now putting all the values, so f a is 1 plus x minus 1 into 2. So I will write 2 here plus x minus 1 square 2 divided by 2 factorial. So it will cancel out. Now solving this, 1 plus 2x minus 2 plus x square plus 1 minus 2x. So 2 1 1 2 x square. Okay, so x square is the answer. Okay, right. Hope you understand this. If you find anything which is not up to the mark, you think so, then you can ask. Okay, so where is the button? Yeah, this, it is all link. Okay, so question we will solve question 28. An evaporator while considering, sorry, an evaporator while concentrating an aqueous solution from 10% to 40% evaporate 30,000 kg of water. The number of solid handled by the system in kg. So I don't think so there is a need to solve this question. Okay, try it yourself. We have solved couple of questions earlier in the previous year questions. So if you find that it is difficult, then I'll just comment, I'll solve it. Okay, this is the similar question. Just take it as an practice question. It will give almost, these two are almost the same. Okay, assuming that CO2, the 2 will come down. Always perfect gas law. Calculate the density of CO2. 2 will come down in kg per meter cube. 3 will go up. Sorry, at 263 degrees Celsius and 2 atm. Okay, so we have to calculate the density. Okay, so very first, a gas. So PV is equal to nRT, must be applicable. Okay, N by V RT. Okay, P is equal to, what is N? N is the, okay, N is the given weight upon molecular weight. Okay, what is N is equal to given weight upon molecular weight. Can write this. So given weight upon molecular weight, V will remain same RT. Now what is this value? Pm. M is the molecular weight. This is density RT. Okay. So density is equal to Pm upon RT. Okay. Now if there is more than two gases, more than two gases, suppose we have a mixture of gas 1 plus gas 2 plus gas 3. Okay, hydrogen, nitrogen, oxygen we have. So then how we will find the density? The only difference will come that instead of the this molecular weight, we will use average molecular weight. Average molecular weight is equal to summation of xi into mi. In the question we have given with the molecular weight of the we know the molecular weight of the all the gases, and we will find the mole fraction and apply this formula, and we'll put here, that is average molecular weight. But for a single component system, molecular weight will come. Even if you will apply a molecular average, then there is only a single gas, so it will give the same value. Okay, 1 into molecular weight, that's all. So just put all the values. Pressure we have, I think 2 atm. So 2 atm, 2 into, we will convert it into kilopascal, into 101.3 kilopascal. Molecular weight of CO2, I think it is 44, if I'm not wrong, divided by R. 8.314 kilopascal meter cube kilomole Kelvin into temperature is 263. 263 plus 273. 536. 536 Kelvin. Okay. Now, molecular weight is equal to kg per mole. Kg per kilomole. So kilomole and kilomole will cancel out. Kilopascal and kilopascal will cancel out. Kelvin and Kelvin will cancel out. C. Kg per meter cube is remaining. Okay. So you will get the density. Okay. So just calculate it. I will not calculate it. I think it is 2 something, I think, if I'm not wrong. Okay. Use of rashing rings in place of crushed stones as packing peg bed. So this rashing rings is only asked twice. I think in 2012 or 2013 there is a question related to rashing rings, and in this question, so you will skip the rashing rings. Okay, just focus on the part which is common in all the papers. Okay, to get good marks in limited period of time. Okay, so a suspension of uniform particle in water at concentration of 500 kg of solids per cubic meter slurry. Suspension of uniform particle in water. Concentration is 500 kg per meter cube. That is density. Density of particle is 25. That is the concentration. That is the density of the particle, of a single particle. And terminal velocity of single particle is this. What is the settling velocity? Richardson and Lady index is this. Okay. So it is straightforward questions. There is nothing. So we know that US upon U naught is equal to void fraction to the power n. Okay, this is, I just write it little bit fancy. E. Okay, so US is the settling velocity. US is the settling velocity. U naught is the terminal velocity of single particle. Okay, so we'll write U. We have to find the settling velocity. So US terminal velocity we have 20 centimeter per second. Centimeter per second. Now here is the thing, how to find the void fraction. See, suspension of uniform particle with a concentration, that means 500 kg per meter cube the particle occupying this concentration, and the density of particle is 2500 kg per meter cube. That means this portion is filled with the particle. 5 1 5, 5 5 25, 5 2 10.2. That means the void fraction will be 1 minus 0.2, that is 0.8. So 0.8 divided by n is the sometimes it is written as Richardson-Zaki index, sometimes it is written as Richardson-Laird index, so it is 4.6 given in the question. Always they will give. So US, just calculate it and you will get the answer. I think between B and C is the answer. Okay. Bed pressure drop in an air fluidized bed catalyst particle density in the diameter of particle 60 centimeter bed depth, and the bed porosity is this. Bed pressure drop, okay, del P by L is equal to G 1 minus E rho P minus rho F. So you will calculate del P from here. Okay. A pitot tube indicate 5 centimeter of water manometer when it is being used for measuring the air velocity. Okay, 5 centimeter of water. 5 centimeter of water, that means very first the velocity of air. Velocity is equal to CV root 2 GH, right, for pitot tube. CV is 1 as it is not given in the question, 2GH, but it is giving the 5 centimeter of water manometer. Manometric fluid is water. Okay, manometric fluid is water. $28.2 is the answer. Okay. Hope you will get this question. Okay. That will come here. Something you will calculate H from here. Okay. Then H, put the value of H here. See, this is 5 centimeter of water of manometer. That means manometer contains water. And this H is the height of the flowing fluid in the manometer. Height of the flowing fluid in the manometer, and the flowing fluid is air. We have to find the velocity of air. So this concept I have taught you, I have told you, not taught, I have told you in the previous questions you are solving. Okay, so I hope you will understand this. So 28.2 is the answer. Okay, now in the distillation, when Q is defined as moles of liquid flow in stripping section per moles of feed introduced, the saturated feed liquid line, saturated, you know that I have told you, saturated liquid line. So just this question is just for 38. In a gas liquid quantum operation, the number of ideal stages n, this is star, this is not 8, this is star. Okay, star. This is true when stripping fraction is equal to 1. Okay, so stripping factor, when stripping factor is equal to 1 equal to absorption factor. Okay, when both are equal to 1. So but okay, but both are equal to 1, then we know that the formula changes. In the previous lecture I have shared my note related to absorption and stripping. Between those two, what the nomenclature you should use so that you will never get confused. Okay, so go through that lecture. I have shared my note. Okay, all the formulas are there. Okay, so you will get this from there. Okay, sparingly soluble gas in liquid, that means M is not sparingly soluble, that means gas is not soluble, and we know that if solute is very soluble, M is very small, very small. Okay. Solute, if solute. If solute is sparingly soluble, that means M is very high. Okay. So if I apply Kx 1 upon Kx plus 1 upon Mky, this is the condition in our question. 1 upon Ky, this is small k, this is capital K. 1 upon Ky plus M upon Kx. So if M is very high, I will put M is very high, so this will become 0. If M is very high, then this will become 0. Okay. So from this we can't conclude anything, but if this is 0, then we have only left with the liquid side mass transfer coefficient. So we have to increase the liquid side mass transfer coefficient. Okay, in order to reduce the resistance, because 1 upon kx is the resistance. If you will increase this, then resistance will decrease, then gas will go more, right? The rate constant of a chemical reaction increase by 100 times when the temperature increase from 400 to 500 Kelvin. Assume transition state theory is valid. Value of E upon R. So that is very just straightforward question. K equal to K naught T e की power minus E upon RT. This is the formula. Okay. ln K2 by K1 minus E upon R 1 by T2 minus 1 by T1 plus ln T2 by T1. Okay, put all the values, you will get the answer. A closed loop system is cooled reversibly from 100 to 50 degrees Celsius if no work is done on the system. U and S. So we have to write an equation. So applying first law, du is equal to dq minus dw. So dw is 0, work done on the system. That means this is negative. So du is equal to uv. UVHP. UV, after U V will come HP, Hindustan Petroleum. So DU will be CV DT. UV for DH CP DT. Okay. HP UV. DQ is equal to TDS. Okay. Now DT by T, if I integrate, is from 50 to 100 and ds upon cv, so it will give a negative sign. That means both will decrease because temperature is decreasing and it will give an entropy in negative sign, so both will decrease. Okay, so this is the section A of the 1995, and within one day I'll try to upload section B as well. Okay, so if you have any kind of confusion, anything in this section, just comment it below. I'll try to reply as soon as possible. Okay, bye guys, take care.